We are going to discuss about the magnetic field intensity and magnetic flux density calculation of the axis of the solenoid. Okay, first of all, you must aware about the solenoid. The solenoid, in the sense, that is a non-magnetic hollow frame. You can take it like that. In that, you can wound the number of turns. Okay, copper or aluminum conductor, you wound like that. While you are giving that positive or negative supply, it may form the magnetic field and magnetic flux density. So that we are going to, that may be realistically many practical applications they may use in the industrial sector. So that is why you need to find the solenoid coil. You can consider the solenoid coil. In that, you are going to find the magnetic flux density and magnetic field intensity. Okay, so now that is the non-magnetic frame. In that frame, you have the number of turns and it's have the total length of the conductor like L and flow of current I, and you can consider the point P in the anywhere in the hollow frame. That's why you are considered the point P. It's have the radius of A, it's have the R distance, and here you are considered the small portion, that is the DL length. So it is starting end of the frame, you have the point, that is the angle, that is the theta 1, and the another end it's have the angle theta 2. So you need to find the magnetic flux density in the point P. So here you see number of turns here present. So that is the current carrying the element. It should be equal. Previously we are using ideal, it was the current element according to the Biot-Savart law. There is no number of turns present. But here the solenoid we are consider, it's have the number of turns, it's have N. So the capital N into flow of current and the total length, that is the L, and we are consider the small portion, that is the current element. So ideal is the current element, but here presence of the solenoid coil, number of turns and total length is present. So capital N into I into DL divided by the total length. Okay, here from this we can find the expression like dB, it should be equal to mu naught into A square divided by 2R cube into Ni, that is the current element, N into I divided by L into DL. So that is the differential magnetic flux density. So in that expression we need to substitute some other parameter from the diagram. So in the diagram A by R it should be equal, that is the A by R it should be equal to sin theta, then R it should be equal to A by sin theta. So why you are finding the A by R? Here the presence of A as well as R it is there, but here the A as well as R is there. So you need to modify the expression. R it should be equal to A by sin theta, that if you are substituted here A cube by sin cube theta it may come. That is why we are finding the R value. You can replace the expression 1. You can consider this was the expression 1. You can replace the R. That is the R it should be equal to A by sin theta. If you are replaced in the R cube, so A cube divided by sin cube theta. So the last denominator can multiply with the, that is the third denominator can multiply with the first numerator. So the sin cube, the remaining term Ni divided by L. So the same thing it has been repeated. So we need to simplify the expression again, because the presence of sin cube theta, we can't make the integration, it was little bit complex again. So we need to simplify again this term. So you need to find, we know that R d theta equal to dl sin theta. So here the dl also there, dl sin theta is there. So you can replace it. Similarly, here from this expression dl it should be equal to R d theta. From this expression we can find dl it should be equal to R d theta by sin theta also we can substitute. So we need to simplify this expression in terms of single sign. Okay, here the sin cube theta is there. So in which way we can replace and eliminate the sin cube theta, so that according to that we can find R d theta it should be equal to dl sin theta. So the dl it should be equal to R d theta divided by sin theta it may come. So if you are replaced the dl R d theta divided by sin theta, here you see here the R term also getting cancelled and sin theta also getting cancelled. Similarly the A, from this relationship A it should be equal to what it will come? A it should be equal to R sin theta. So the A it should be equal to R sin theta. Okay, so you can replace all the term in the previous expression like this. So the A you can replace it. Similarly dl you can replace it. So this two you can replace it. So the mu naught into sin cube theta Ni divided by L, instead of dl R d theta divided by sin theta, instead of A R sin theta. The remaining two you can repeat again. So the A, instead of A R sin theta, so the R and R it may getting cancelled, sin theta and 1 sin cube theta, it's have 3 sin theta no, so it may getting cancelled 1, and another 1 sin theta it is cancelled here, the remaining only 1 sin theta. So the remaining expression mu naught into sin theta into n into I into d theta divided by 2L. That is the simplified form. You can rearrange the expression again, the sin theta into d theta. Why you are rearranging? Because we need to make the integration. So the constant term, the mu naught into I, n into I divided by 2L and sin theta into d theta. So you can make the integration with respect to the corresponding limit, but because here the limit was theta 1 as well as theta 2. Okay, in the solenoid coil, the starting end and the another end. So the theta 1, here it is the theta 1 is the initial angle, here it is the theta 2. That is the theta 2, that is the pi minus theta 2, because if you are consider any straight conductor, here the angle have the theta 1, here if you are consider the angle, that is the theta 2, this angle is directly we can't take it, so that is the total angle is, that is the pi, that is the 180. So you have to subtract it, that is why here the limit is pi minus theta 2, right? So that you have to substitute here, so that is the theta 1 and pi minus theta 2. So while we are making the integration of sin theta, what it will come? Minus cos theta, then upper limit minus lower limit. Upper limit you know pi minus theta 2 cos pi minus theta 2 minus cos theta 2. That is the formula. So likewise you can simplify. Here B it should be equal to mu naught Ni divided by 2L cos theta 1 plus cos theta 2 Weber per meter square. That is the unit of magnetic flux density. So that is the total and resultant magnetic flux density of the solenoid. Similarly, from this relationship, you know the mu it should be, that is the B it should be equal to what it is, mu into H. You never forget this relationship. So the mu it should be equal, B it should be equal to mu into H. So H it should be equal to what it will come, B by mu. So you can replace it. So the mu alone it may getting cancelled. You know this relationship. From that we can find the magnetic field intensity. H it should be equal to Ni divided by 2L. Then cos theta 1 plus cos theta 2. So that is the resultant total magnetic flux density and magnetic field intensity in the solenoid coil. Okay, but in this case you need to consider two different cases. You are considering the point P, that point P, that is the point P. If you are consider the solenoid coil, that point P it is the center of the axis. If the point P is the middle axis, its the total length is L. Okay, the total length is small l. If you are consider the point P in the middle of the solenoid coil, okay, theta 1 as well as theta 2 it should be equal to same, that is the theta. So you can replace theta 1 it should be equal to pi minus theta 2 it should be equal theta. It means that theta 1 and theta 2 both are it is equal to theta. So if you are substitute theta 1 and theta 2 both are equal in the total expression, theta 1 theta 2 both are the same, means the cos theta plus cos theta, the 2 cos theta it may come, so the 2 and 2 it may getting cancelled. So what it will come, that I written here, the 2 may getting cancelled. So the resultant magnetic flux density mu naught Ni divided by L into cos theta. That is the case 1. If you are consider the point P in the middle of the solenoid coil, in the sense both middle of the solenoid, if you are consider the middle of the solenoid coil, both the side the angle was the same. That means the theta 1 as well as theta 2 it's have 45 degree. Okay, both are it should be the same. Okay, that is why the 2 cos theta it is came. So 2 and 2 it is getting cancelled. So remaining mu naught I n into I divided by L into cos theta. That is the resultant magnetic flux density of the solenoid coil when you are considering the mid axis. Okay, similarly the same expression you can find the magnetic field intensity also, that is the H equal to n into I divided by L cos theta. That is the case 1. If the second case, if you are consider the point P, if you are consider the point P in the end of the line, if you are consider the point P like this, if you are consider point P here, the theta 2 is 90 degree, then theta 1 it may getting changed. Okay, that is the second case. So the theta 2 is the point, sorry, 90 degree. If you are the theta 2 is the 90 degree, the value is 0. So the theta 1 alone it may come, right? So B it should be equal to mu naught into N I divided by 2L cos theta 1. If you are consider the point P in any one of the end, okay, any one of the end, that angle was the theta 1 or theta 2, it may be the, if you are consider the end of the line, that is the end of the solenoid in this side, so it's theta 2 it is the 90. Suppose if you are consider the end of the side here, the theta 1 becomes 90 degree like that. Okay, if you are consider here the starting end, you can another end, that is the ending end. So if you are consider the point P here, the theta 2 is 90. If you are consider the point P here, the theta 1 is the 90 degree. So if the 90 degree means cos 90 value is 0, right? So the remaining one angle, that is the, what is that? So remaining one angle, if you are considered here, the theta 2 is 0. So according to that, I written here. So here the theta 2 is the 90. So cos theta 2, it will not come because it is 0. The remaining expression it will come b equal to mu naught into ni cos theta 1 by 2l. So you can rearrange again magnetic total, magnetic flux density, magnetic field intensity. The mu naught again, it may getting cancelled, mu I divided by 2l cos theta 1. If you are consider the point P here, instead of theta 1, theta 2 it will come. Okay. So that is the total resultant magnetic field intensity and magnetic flux density calculation of solenoid coil. Okay, the solenoid coil you can consider at any point, you can consider and you can apply this expression, you can find the resultant magnetic field intensity and magnetic flux density. Okay, go through it. If you have doubt, you may ask. Okay, thank you.